All right. All right, buddy. So here we are with my budget rig. We're still at the Kennedy Space Center in NASA. And of course, I'm at the Swarmathon competition. I'm standing next to the creator of the Swarmathon robotics competition, Dr. Melanie Moses. Hello.
Hi there.
So,
Melanie.
Oh, sorry, I keep doing this.
It's okay.
I'm terrible at this. I'm sorry. Melanie Moses. There we go. All right. So, so here we are at the Swarmathon competition, and I wanted to get a word with the busy doctor here. So, Dr. Moses, what are we doing here? What is this competition?
So this is a swarm robotics programming competition. We started this competition 3 years ago with NASA's funding, and our concept was we wanted to have a competition where students got to really focus on the software side of robotics. So there are a number of competitions where it's about building the robot and the physical design of the robot. In this case, we designed these robots. We didn't design them to be great robots. We designed them to be flawed robots, so there's lots to fix in software.
That's how you
learn.
Lots,
that's how you learn. There's a lot to overcome. There are a lot of shortcomings with these robots. They're cheap robots. We built them and designed them ourselves with a bunch of students from the University of New Mexico. And then we have sent these robots out into the world. We sent kits to various teams, so they have them to practice on, and then they have to upload their code in GitHub to us. We download that code onto the robots here at Kennedy Space Center, and then the robot's job is to drive around in these arenas, locate these little cubes with April tags on them, little codes that let the robots know this is what I'm collecting. And the team that brings the most of these cubes back to the center collection zone wins.
So the goal here is to not only get the kids to apply their programming skills into making algorithms that make these robots accomplish the task, but these robots are, you can imagine these robots could be used in space, right? So you have small,
Absolutely.
dumber robots, simpler robots, working together in a pack to accomplish the task of maybe collecting resources?
That's exactly right. So the mission that we are associated with was the journey to Mars, although this really works on any kind of interplanetary exploration, any surface of the moon, anywhere where you want to send humans. But what you need for humans to survive when they get there are resources. So for example, you might need to collect ice on the surface of Mars, which you could turn into water to drink and oxygen to breathe and hydrogen to fuel your rocket to get back home. So the idea is that these robots could go around on the surface of Mars, for example, looking for small patches of ice that they could then harvest and bring back to a center place. And it could be all kinds of other other kinds of resources. People are often thinking about prospecting for valuable resources on other worlds. And our vision has been that multiple robots collaborating together are going to be enormously faster than a single robot attempting to do this on its own, even if it's a really high-tech, expensive robot like the Mars rovers that have been up there before.
Makes total sense. I love the activity. So you have 21 teams here today.
We do, and they're doing a fantastic job.
So tell me about, how did you get started with this? So what inspired you to create this program?
Great. Well, interestingly, what inspired us to do this work was ants. So when we look at here on Earth, what are really ecologically successful animals? Ants are really successful at searching the area, the picnic ground, or whatever it is, all around all kinds of different ecosystems on Earth are really dominated by ants that collect lots of resources. So our initial work in this space was actually to use an algorithm that we tested out here. It was called the Central Place Foraging Algorithm that really encoded the behaviors of ants. So rather than doing something like a lawnmower search that's very predetermined and exact, we used a more stochastic or random approach, where the robots start in the center, they search just at random, and if they find some kind of a resource, then they have to bring it back to the nest, but they also communicate to the other robots, hey, there's something over here. And that can be really effective when things are distributed in patches, which many things out in the natural world are.
Excellent. All right, so let's talk a little technical. What are these robots made out of? I've noticed some ultrasonic sensors. Maybe there's Arduino on there?
Yeah, so there's an Arduino on board, and we've got...
Hi.
Yeah. And there's this is my partner in crime here. We are live on YouTube.
Yeah, come on.
Want to jump in and she's running away. At least come on over and say hi. So this is Teresa Martinez, who has funded this competition.
So Lisa, what do you do?
NASA Education.
Teresa. So I'm in education. I'm an electrical engineer. Worked out here a long time on Space Lab.
Oh.
And so right now what I do is provide grants to universities And Melanie was the recipient of one of the solicitations that I put out, and that solicitation was to run Swarmathon. We said, hey, we need a competition. Who wants to run a competition for something that NASA is interested in? And that was Melanie.
Wonderful. Well, it was very nice meeting you. Thank you.
And I will try not to interrupt any more live
That's okay. That's perfect. See?
That was perfect
Get first
interruption.
names right, so this is great. All right. Very nice meeting you. All right.
Teresa.
Back to Melanie, Dr. Moses. All right. So we're talking about the makeup. I saw some ultrasonic sensors. What is the makeup?
Right. So there are ultrasounds on there. That's how they do their obstacle avoidance, which actually is really interesting. It's gotten much better over the years. We had a lot of robots crashing into walls in the first year of this competition. This year we've seen some of that. Interestingly, that's often not a hardware problem. It's a software failure. So the software crashes.
That you can fix.
That you can fix, although not during this competition, right? These are preloaded, and so when you see your software crash out there, you just have to watch and cry. There's not much you can do about it, except learn for next time. And that's been really effective. So students have gotten, over the years, much better at using those sensors appropriately. So we've got ultrasounds on there. We have cameras, and the camera's main job is to find those April tags, those black and white patterns on the cubes.
Okay.
And those are sort of automatically detected. There's an Arduino that is the interface between a NUC, it's just a Linux machine that's doing all
Linux.
We're running Linux, of course we're running Linux, and there's an Arduino to do the low-level control to talk to the sensors and the actuators, the wheels. There's a gripper on there.
Excellent.
So it's a fun little robot. There's certainly nothing fancy on there. All these things are things you can buy off the shelf. And in fact, if you go to nasaswarmathon.com, you will see the build guide. So you can get these parts. You have to custom print a few of them, 3D print them, but folks can build their own robots. The software that we provide the teams to get started, that's all freely available on GitHub. So there's links to that online.
All right, so how does one support your initiative here?
Well, there's a lot of kinds of support. So the thing that we care most about is getting students involved. I think we've had just amazing students, over 1,000 students from colleges and universities across the country have participated. And those students are all from minority-serving institutions. So they're Hispanic, have large Hispanic populations, things like historically black colleges, tribal colleges, and these many community colleges. And these are often universities that don't have a whole lot of money and resources, and so students don't realize that they have incredible talents that can help solve problems that NASA cares about, right? And so we are really working with the Swamp Works group here to think about how do we solve this problem of collecting resources on other worlds, and this is an approach most places haven't taken, and the students are making real contributions.
That's wonderful. I always say there's two universal languages: music, number one, okay, maybe dancing, and technology. So technology will put people together, and I love to see more diverse groups expanding into this arena and making a showing and learning.
Absolutely.
So what would you say to schools and teachers out there, on the board, or professors that are not yet involved in something like this? What would you say to them? How do they get started?
So we'll direct everyone to nasaswarmathon.com. If you are interested in participating, there's a sign-in. Let me know when the application's open for next year. So give us your name, and we'll keep in touch with you. Poke around on the website. There's all the information from the past years and a little bit of the history of the robots, some of the technology. You can watch videos where the robots are behaving or performing their algorithms out here in physical robots and also in simulation. And if there's anybody out there, the other kind of sponsors we care about are fiscal sponsors. So we have Google, who's provided some money. We're always looking for companies and industries that want to encourage.
I love YouTube.
That's right. To encourage young students, particularly students who don't necessarily see themselves as scientists and engineers, to give it a try. There's some remarkable talent out there in small schools all around the country. This way those students kind of find each other, they form a team, they get to know students and faculty, again, from around the country, and they can make real contributions to the future of this kind of technology. So
I can tell not only you're a great leader and a great organizer, but you're a wonderful person. And it was a pleasure talking to you.
It was wonderful talking to you.
I don't want to take any more of your time. I know you got a lot of stuff going on, so I'll talk to you guys about the competition more in depth and give you all the details. But in the meantime,
all right. Thanks so much for inviting me here, and we hope to see you guys sign up on NASASwarmathon.com.
Awesome. Thank you so much.
Thank you very much. Bye-bye.
Thank you.
All right.
All right, so guys, just remember, visit JLC PCB. They helped sponsor me to get here at NASA. I appreciate it. Signing off. Bye.